Thank you, Beth, and thank you to JCATI for giving me the opportunity here. Let me get my presentation shared. Okay, so yeah, thanks again for this opportunity. This is an area, both of these markets, air mobility and unmanned systems, I've been doing quite a bit over the last few years. My position at Hexcel is really to look after these emerging markets and making sure that we have the right material solutions and the right manufacturing solutions to be able to support them. And so what I'm going to present to you today is really just kind of our view on this market, some of the challenges that still exist in these markets, what the opportunities are, and some of the issues, and look forward to questions on the topic, and hopefully I'll be able to address them. Just as a little bit more background on myself, I lived up in the Seattle area for 11 years and taught a few classes at University of Washington. So I've got that tight relationship with the University of Washington, and look forward to further collaboration with a lot of the activities that are going on in JCATI and in the state. Okay, so just if you don't know Hexcel, I imagine most of you know Hexcel, but we're a major supplier of composite materials and structures primarily to the aerospace market. We do some work in the industrial market, but the bulk of our business is aerospace, both commercial and defense. So we manufacture carbon fiber. We do the pan in Alabama, and then make the carbon fiber in Salt Lake City, which is where I'm based. We are the second largest producer of carbon fiber in the world, and the largest producer of intermediate modulus carbon fiber in the world. We also then develop a number of resin systems, and I'll talk more about that throughout the presentation, to create a number of prepregs. These can be unidirectional or fabric prepregs. We're also a major weaver of both glass and carbon fiber products, which we do in Texas. We got into the additive manufacturing arena a few years ago through an acquisition. I'll talk more about that. And in addition to carbon fiber prepregs, glass prepregs, and then we are the largest producer of honeycomb core materials in the world. That's both metallic and non-metallic honeycomb core. And then we also build engineered structures and have two plants in Washington State. We have a plant in Burlington that is an engineered core facility where we take our honeycomb core and we shape it and form it and bond it into sandwich structures. And then in Kent, Washington, we have an engineered structures business where we build a lot of flight critical components for rotorcraft, commercial aviation, defense aviation, as well as space applications up there. And we tend to focus on very complex composite structures and have some real expertise in being able to develop that. So that's kind of an overview of Hexcel, if you weren't familiar with all of that we're involved with. So in regards to the topic, let me first address advanced air mobility. A lot of press on this topic. You'll see it as eVTOL or urban air mobility. NASA has tried to recoin this to advanced air mobility, and it is gaining some traction in terms of that terminology. The reason that they wanted to do that is that originally it was, talked about urban air mobility, which was, as the name suggests, transportation in an urban environment. A classic example would be getting from New York's JFK airport to downtown Manhattan. And if you could do that in 15 minutes on an air vehicle versus an hour in a taxi, and if the cost were similar, there'd be an attractive market for that. But there's a lot of other applications for this technology that is beyond urban transportation. So you think about areas that maybe are underserved, up there in the Pacific Northwest, it would be getting, from Seattle to one of the islands, or Seattle to Vancouver, for example. The Vancouver area to get, to Vancouver Island from Vancouver City, so forth. Cape Cod's another market that's being looked at. So those aren't urban, but they're really just more efficient transportation. And then there's a lot of interest in this market for just things like, emergency transport for medical emergencies, or things like logistics in areas that might be difficult to get the product there by truck, for example. So a lot of different applications. As I mentioned, a lot of money flowing into this. Nobody's certified a vehicle yet, and nobody's, actually purchased a vehicle. There are purchase orders that are in place for a lot of these companies once they certify a vehicle. But if the market develops the way the companies in this space are projecting, it will be a very large market, and it will be largely a composites market. None of these players are looking at metal airframes. They need composites for the weight efficiency in order to be able to, because these are battery operated, and so weight's going to be pretty critical. There are a variety of market research reports out there that talk about the size of this market. A little difficult to predict right now because it's not a real market yet. But here's just one from one of the studies that I would say is more conservative in their predictions, showing pretty sizable growth rate, 33% market growth rate, getting up to $7 billion market by 2030. There are some market research reports that show it is higher than that. But it's dependent on a number of things, as mentioned: certification, how you're going to handle the air traffic management, the business model, having the infrastructure to be able to support this kind of market. So a lot of things that still need to be addressed before this market's real. But we're excited to be part of it and to be engaged with a number of these companies out there. Let me talk about UAV markets, because UAVs have been around for some time, but there's increased emphasis, especially within the Department of Defense, to go more towards unmanned systems. Definitely lessens the risk to pilots. The unmanned systems can, be built in larger quantities, so that you could have potentially swarms of these drones out there. Even talking about some of the new fighter aircraft could be potentially unmanned, or be able to have the capability to fly unmanned. So this is kind of the roadmap from the Air Force in regards to what they're trying to put together over the next 25 years for unmanned systems. One of the terms that now is more common in this industry is attritable. Attritable means that it's an expendable vehicle. And so a lot of focus on high rate manufacturing, low cost manufacturing, where they could pump out hundreds of these drones in a month, and to be able to support a mission with the understanding that, they may only fly one mission and be destroyed after that mission, but be able to protect our warfighters and not being exposed to the danger there. So if you look at what the projections are for composite materials, here's a market research report that we purchased last year that looked at what's the composite material market potential for the unmanned aerial vehicles. And here in this chart, they've got it split out between the different regions in the world. But they are estimating that by 2028, there's a $2 billion market for just the composite materials on these unmanned systems. And you can get similar types of projections when you look at urban air mobility and even beyond a $2 billion a year market for the composite materials. So with these different markets, what we're finding is that really the mission profile is what defines the material requirements. So, for example, if you're looking at a UAV that's attritable, you're going to look at a low-cost material that can be cured very quickly so that you can pump out a lot of these in short order at low expense. Whereas an urban air mobility that's carrying passengers, they're tending to want to use established materials with established procedures on this, but are looking to the future that as this market develops, they will want to switch to high rate material systems to be able to meet their rate targets. Some of these companies are talking about getting to rates of several hundred to possibly even a few thousand vehicles a year. So that will put that will put different constraints on the material suppliers and the manufacturers in order to be able to meet those needs. So here's kind of a high-level summary of what we're seeing. So on the left-hand side is the types of requirements that we're being exposed to be able to support these markets. One is they want higher build rates. As mentioned, they want to get to build rates that are beyond what we currently are used to for commercial aviation. They want lower cost. On the UAV front, they want lower cost because these are going to be expendable vehicles. On the urban air mobility, they want low cost because they've got to create a business model where it's attractive to their customer base. And as such, they need low cost vehicles. But with both of these markets, they still need that aerospace grade and quality. And then there's a lot of different trade-offs that are going on in terms of the part size, the complexity. If you're going to use automation equipment, how's it going to perform? Is it urban air mobility or advanced air mobility where it's got to survive for years and operate on a very regular basis versus a UAV that may sit for a period of time until there's a need to deploy that UAV in a warfighting situation. How are you going to maintain these vehicles and maintain the materials? How are you going to repair these materials if they get damaged in flight? And then from that, you pivot over to what are the manufacturing methods that you're going to look at. Obviously, in order to be able to meet the high rates, there needs to be a lot of automation. And so things like AFP and ATL are appropriate technologies. How much can we use additive manufacturing? We're seeing a lot more interest in resin transfer molding, compression molding types of applications to get these materials out of an autoclave and be able to produce those at high rates. And when you look at the journey that companies have to go through, many of these companies are startups and they're hiring from the aerospace industry, some from the automotive industry. But here's all the different steps they've got to go through. They have to go through a material selection phase, then they have to qualify that material. They have to design a vehicle with those material properties. They have to do some prototyping, testing, get into initial production, certify the vehicle, produce the vehicles, and then look at the next model. And as Hexcel, we're engaged in all of those activities and can support customers with that. But regardless if it's Hexcel or another material supplier, these are all the steps that companies have to go through, just like with any other certified air vehicle. And I'll go into some of these in a little bit more detail as we go forward. So first on this material selection. So, obviously there's the common material properties, stiffness, strength, toughness that are required. A lot of these companies are startups, and so they're still actually defining what the material requirements are in regards to stiffness, strength, and toughness. But in general, they're very focused on getting vehicle designs that are as lightweight as possible so that they can operate efficiently. Then once they've selected the materials, and actually as part of the material selection is what's the manufacturing process that they're going to use. And again, a lot of this is still unknown with these emerging markets, and they're looking at it. I would say for urban air mobility, there seems to be a trend right now, a tendency to go with more established manufacturing processes to ease the path of certification, and then to pivot to higher volume manufacturing materials as they kind of get established in the market. But all of these different manufacturing methods, as mentioned here, are being considered. And then as focus, as I mentioned, there's a big focus on cost here. And what we're finding is that it's less dependent on the material cost and really looking at the total cost of materials and manufacturing in order to be able to do that. So a lot of interest in automated integrated structures, for example, to reduce the part count so that they can really manufacture these at the high volumes. And if you look at what it takes to develop a material system for carbon fiber composites, is you've got the carbon fiber activity, and there's various grades of carbon fiber out there. You have the matrix chemistry, and what you want to have is to be able to have a very good compatibility between the sizing on the fiber and the matrix that you're going to use. So you've got very good translation properties in translating the load from the fiber to the matrix material. So a lot of interaction that has to happen between the fibers activity and the matrix activity in order to be able to come up with prepreg solutions or other solutions that meet the needs. And then once you have that chemistry all defined, then you've got to develop the manufacturing capabilities so that you can produce these materials in high volumes with consistent quality and repeatability. And so there's a lot of manufacturing science that comes into that. So it's a very involved process to develop a new prepreg material system. And so as the requirements evolve with these emerging markets, we'll be involved in working with them in order to be able to come up with the material performance that they need to meet their requirements. Summary on carbon fibers, we kind of have this separated into three buckets. You've got the kind of standard modulus fibers, which are our AS grade fibers, and you've got the intermediate modulus fibers, and then high strength. What we're seeing is that in the UAV market, primarily interested in the standard modulus fibers. A lot of that is driven by cost and the fact that these are going to be attritable vehicles. Some interest in some activity with intermediate modulus, but I would say primarily it's in the standard modulus fibers. Air mobility, we're seeing clearly interest in the intermediate modulus fibers, and the higher the strength, the better. Because this helps them reduce the weight of the vehicle, which is important for their business case. No real interest in the high modulus fibers. As you can see, there's a drop off in strength as you go up in modulus. And so no real interest from either one of these markets in high modulus fibers. On the prepreg side, we're seeing a mix of interest between thermoset and thermoplastic prepregs. Thermosets have that legacy, can be simpler for certification, a lot of knowledge on thermoset prepregs that are out there, but a lot of interest in thermoplastic prepregs for future vehicles because of the, some of the advantages thermoplastics provide, which is, you don't have to store it in a freezer. It's got mostly unlimited shelf life. It doesn't need to be cured in an autoclave, although we still see a lot of autoclave cure of thermoplastic composites today. And then once you select the material system, then you, as I mentioned, you have a selection process in regards to what type of manufacturing method you're going to use to lay up and cure the structure. One of the things that we've been doing is that based on this requirement for higher rate material systems is looking at a lot of our legacy aerospace prepregs and seeing what could we do to reduce the cure cycle time. And I'll talk about that as, one of the prepreg systems that we're looking at to do that. But, if you could reduce the autoclave cure cycle by 25%, when you're talking about producing hundreds or even thousands of vehicles in a year, that can have a big impact on the cost of manufacturing. So we're really looking at that. And then the other thing, which is reflected here on the bottom left, is that we've got a lot of industrial materials that have been produced that are high rate out of autoclave systems, but generally don't have the aerospace material requirements needed for these markets. So we're looking at what can we do with those material systems that are well established in the market to improve the material properties so they become more aerospace grade. So an example of one of the things that we've been doing on, looking at the cure cycle. So this is with our 8552 material system, which has been in use in aerospace for decades. It generally is a 5 to 6 hour cure cycle in an autoclave with that material. But we're looking at different cure profiles to be able to reduce the amount of time in the autoclave, with a target of if we could get down to 4 to 4.5 hours, that provides a 20 to 25% improvement in the cure cycle. And what kind of impact would that have on the material properties? Some of our initial studies are showing pretty good results, that there's very limited impact on the material properties. You still might get 95% of the material properties with this. And so we want to be able to explore that in more depth so that we can provide that as an option to companies if they want to stick with an autoclave cure material, but looking at ways in which we can reduce the cure time. And then on the topic of taking industrial products and seeing what we can do, M77 has been our snap cure legacy system. It's been out there for decades, used in the industrial market. Generally has a 1 to 3 minute cure time used in compression molding, but it doesn't have a very high TG. And so for these new market segments, we're looking at what can we do to increase it. And we've got a product that's in development called M901, where you can get up to 190 degrees Celsius dry TG, which is in line with other aerospace material systems that we have that are cured in the autoclave. Infusion. So there's a lot of interest in infusion. Infusion's been around for some time and used in some secondary structures in aerospace today. Infusion provides you the opportunity to be able to develop large integrated structures and to be able to cure them in a single process. We've got a number of infusion resins, continue to develop new infusion resins for this market. We also have some dry fiber products that are compatible with all of our infusion resins that allow you to use automation in laying up the preform for this. And so infusion really does hold a lot of promise. Things like rotor blades for urban air mobility are a great candidate for infusion, but they're also looking at some of the primary structure and secondary structure on these vehicles of where infusion could be used. The capital equipment is generally less intensive than an autoclave cure system, and it just holds a lot of promise for this market. I did mention thermoplastics. As mentioned, there's some advantages with thermoplastics. The materials themselves tend to be a little bit more expensive than thermoset prepregs, but they do offer this flexibility and not needing freezer storage, can be cured out of the autoclave. And so we decided to get involved in developing thermoplastic prepregs a few years ago with a joint partnership with Arkema, and are developing these materials in France currently. But we supply a lot of carbon fiber to other prepreggers that have thermoplastic prepregs out on the market. And I would say there's high interest in second generation vehicles for urban air mobility of being thermoplastics because of these advantages, but probably won't see thermoplastic materials used on first version of the vehicles, although there are some companies out there who are planning to go to market with a thermoplastic prepreg for their first offering. We're also seeing a lot of interest in honeycomb. As mentioned, there's a big focus on weight reduction. Honeycomb is a great option for weight reduction. It gives you that bending stiffness without adding a lot of weight. And so we're seeing most of these vehicles, especially with urban air mobility, some with UAVs, of using honeycomb cord structures. The new thing that we're seeing is that they're looking at fairly thin plies on each side of the sandwich structure. So, I think the aerospace industry is pretty comfortable with 8, 10, 12 plies core, and then same on the other side. But what we're seeing from these newer markets is things like two plies, 4 plies, and then a cord structure. And so that'll lend to some, additional evaluation of how we build structures with, a thin number of plies in the cord structure. Honeycomb is used today throughout aerospace, well understood. We're currently doing an in-camp qualification of a few of our honeycomb materials that are being used extensively in aerospace. They're used for, in all of these, both interior and exterior applications. The other thing that we're seeing quite a bit of interest in the honeycomb is that we had developed a product a number of years ago called AcoustiCap, which is really focused on the engine nacelle market. It has some sound dampening capabilities in that, really to mainly reduce the noise from the engine to the outside. And that's heavily used in commercial aviation today. We're seeing a lot of interest in the urban air mobility market in particular for acoustic solutions, because they will operate in an urban environment or a populated environment, and they need to be quiet and so forth. So I think there's a lot of more activity that will be done in terms of acoustic materials that'll be used in these vehicles. They're also very concerned about protecting the noise in the cabin. So passengers, some of the companies we've talked to have said their goal would be to not have passengers have to wear headphones and still be able to carry on a conversation in the vehicle. So having good acoustic solutions will be important for this market. I do want to touch on additive manufacturing. As mentioned, we got into this through an acquisition a few years ago. We are currently producing additive manufactured components using a PEC material loaded with chopped carbon fiber. So it's about 15% by weight carbon fiber. PEC is a high performance thermoplastic, and we're seeing quite a bit of interest in this material. And this material is being used today in both commercial and defense aviation. We've had a number of engagements. In the middle here is our engagement with Boeing, where we're now qualified for Boeing for both for their commercial and defense aviation capabilities. On the left-hand side is a press release with General Atomics, which is a major player in the UAV industry, and they're using more and more additively manufactured components on their UAVs. These are the types of parts that we're producing. So we're generally looking at like ducting, casting replacements, things where you've got fairly complex geometry, where the tooling could be quite expensive, and producing these parts. They're lightweight, structurally sound, have very good thermal capabilities that can handle a wide variety of temperature ranges. And these parts, with our system, these parts come out of the machine pretty much ready to go. There's no removal of support structures on this, and generally the surface finish is good. And so these are the types of parts that we're producing today with additive. Wanted to talk a little bit about material qualification. I would say one of the things that we're seeing with this market, especially with advanced air mobility, is that in the past you had a number of OEM primes like a Boeing, like an Airbus, like a Northrop Grumman, Lockheed Martin, who basically developed the material allowables with an internally funded qualification activity. But these emerging markets generally don't have any appetite for developing the material qualification on their own. So they really want to tap into public databases of material properties. And so there's just, NIAR is getting very busy from us and from other material suppliers, because this market is really demanding that these materials be qualified through public databases, and then they will just tap into those databases in order to be able to design their vehicles. And then material design and analysis. The other big request that we're getting, both from this market, but even our legacy market, is that they not only want the material qualification data, but they want it formatted so that it just is ready to plug in to simulation tools that are being used today. So we've been very active in developing this material data set, formatting it into the formats that are required for the different analysis tools. So that includes process simulation, so things like resin transfer molding simulation, autoclave cure simulation, being able to have all of the material data to allow our customers to be able to do those simulations. And then more and more virtual material characterization before they commit to the physical material and doing all of the physical testing required for qualification. How much of this can they do virtually? So that they can start to use some of the virtual material qualification data prior to the physical qualification being completed, so that they can move fast in their design studies. And then also being able to provide all of the material properties to the structural design and analysis teams who need to design the vehicles with these materials, and they want all of the A basis or B basis allowable data in there. They want it formatted appropriately for the different simulation codes that they might be using. And in fact, some customers have said they will only consider new materials from Hexcel if it comes with a digital data set with the material. So we're, as I mentioned, we're active here, and this is a demand that's coming from these emerging markets of having this full set of digital simulation tools. I shared this before, I'm just repeating it here about all of the number of steps. When you look at these emerging markets, they're generally kind of in the material selection to prototyping phase. Some are starting to move into the testing phase, but there will be a lot of activity over the coming years in the setting up the initial production, certification, and full production of these vehicles. And we hope that these markets are very successful. It's a big boon for the composite materials industry in general to have these new markets and the types of volumes that they're talking about, and getting more people very comfortable with flying on vehicles that are heavily composite. I wanted to address a couple of other issues here that I think are important to consider here before we move into the Q&A. So one is the supply chain. So let's say advanced air mobility is successful, they get to rates of thousands of vehicles in a year being produced. That is really going to stress the current supply chain for composite structures. So there's a few things happening. Some of the players in advanced air mobility have engaged with automotive companies. So Joby has a tie-up with Toyota, Fiat Chrysler is an investor in Archer, Hyundai has entered the mix. They've rebranded this to Supernal, but it is a wholly owned subsidiary of Hyundai. General Motors has expressed interest in getting into this market. You have the aerospace suppliers. So Boeing has teamed up with Kitty Hawk to create Whisk. Airbus has announced plans to get into urban air mobility. Honeywell, Bell, Spirit have all announced interest into this market. So the big question is is how's the supply chain going to evolve? Is the automotive supply chain going to step up their composites manufacturing capabilities to be able to support this market? They definitely have the experience in high rate manufacturing, which is important. Or will the aerospace market step up to increase volumes and capacity in order to be able to meet this market? Because the aerospace industry has the knowledge and expertise of certification and being able to manage the process of qualifying production facilities for aerospace applications. Or will a new supply chain emerge? Too early to say. It might be a mix of all of these, but it's an important area that I know both the Air Force and NASA have been looking at, to saying what's needed in order to be able to support the supply chains to meet the requirements of these emerging markets. So again, just here, is it an automotive supply chain, an aerospace supply chain, or a new hybrid supply chain that will emerge here? So to kind of finish up here, and then we can move into Q&A, here's just some resources that we have on our website for both of these markets. It's got some white papers, it has data sheets and other things. So I encourage you to take a look there if there's some more information you want to see on these markets. And then I also wanted to mention one of the things that I identified as I started exploring these markets is that many of these companies are in that early stage, and they're in that prototyping stage, material evaluation stage, and often they only need a very small amount of material to be able to do that. And we were constrained a little bit in being able to support that market. So last year we set up 2 distributors. One's in Washington State, HECON, the other is on the East Coast, that are now stocking prepreg materials for these markets, and they can supply these materials in small quantities and on demand. And we'll continue to support these distributors, and we've got a very flexible arrangement with them in terms of the types of materials that they stock. Currently, they're stocking 8552 materials, which is a legacy autoclave pure epoxy resin system, and then our M77, which is this snap cure material system that's being used more and more by the UAV industry. And we'll change the mix of the materials, but wanted to just alert this crowd that we've got that set up now in order to be able to support the materials needs for companies that are in this early stage and only need small quantities. And then the other thing that we announced last week is that we also see a lot of interest in this market for prototyping and engineering support. And so I mentioned our Kent, Washington facility, which is great for production work, but we really don't support prototyping or engineering for that. And so we've now partnered up with these 2 companies, Fiber Dynamics in Wichita, Kansas, and Rebuild, which has several sites throughout the US, who have a lot of capabilities for prototyping and engineering support. And so for these emerging markets, they are our partners that can help with those activities as these companies are developing their designs and getting them certified and getting the prototypes manufactured. So in summary here, these different markets do have different material requirements, and so it's not a one-size-fits-all type of market. UAV has very different requirements than urban air mobility and so forth. So it really, we want to engage with companies and help them make the right material selections depending on what their market needs are and what their technical requirements are. We are a global leader in advanced composite technologies, continue to invest. We announced last year that we're building a brand new state-of-the-art research and technology facility in Salt Lake City that's supposed to be completed at the end of the year, so that we can continue this activity in developing the new material systems that will meet the needs of these new emerging markets. And happy to engage with companies at any stage of the process, and to be able to support you as you go through this journey on it. And then just to finish up, here's my contact information. Feel free to email me if you've got specific questions on any of these topics, and happy to support. So with that, I'll turn it back over to Beth and address any questions that have been asked.